Welcome back. This is year 2024, and this video is about who uses machine learning and for what. This is a 2024 update because I had a similar video called Who Uses Data Mining and What For in 2012. I recorded this video 12 years ago as part of my first flipped classroom course called Business Analytics Using Data Mining. And the question is, what changed since then? For example, you see that I'm using the term machine learning now and not data mining, and that's because the term changed, not necessarily the methods themselves. Let's see what happened in the last 12 years. I would say that generally, machine learning, or what used to be called data mining, is still very much heavily used for business analytics in both the commercial and non-commercial world. What really changed is scale. And I'll talk about three main things related to scale. One is there are many more applications of machine learning in everything that businesses do. Secondly, there's a lot more data to train on. There's bigger amounts of data, meaning on more people. There's a lot more behavioral data because we're doing everything digitally, so it's easy to record. We have much more fine-grained data, knowing exactly what we're doing. And it's much more 360 because many of the companies have merged or purchased each other, so they have a lot more information on us from lots of different angles. The data are very networked, so we can see who are connected to who and doing things together with what. So the information is more networked and people, users, are more networked as well. And there's a ton of what we call unstructured data, such as text and audio and video, that was just not there back then. We have technologies such as social media and the Internet of Things, or IoT, that have created a massive amount of these kinds of data. And we also have tons of images that people have been posting, and there's more space for everyone to post it. So there's just a lot more data. The third element of scale has to do with the models, and they're much bigger and more complex, and even what we call black box models going around deployed everywhere. So let's see how these things played out. First of all, in terms of big models, the big thing was deep learning, or DL. And deep learning really took off in the last 12 years because deep learning needed a lot of training data and a lot of computational resources. And both of those became available, mostly to the very big companies. What kind of data have become available? As I mentioned, tons of text, voice, images, and video. And what's special about the deep learning technologies is that they can actually utilize these kinds of unstructured data that the more traditional machine learning methods were not as easily able to use. We've seen lots of new innovations. So for example, Google Translate made a huge leap in the abilities of translation when they switched to using deep learning. And that happened almost overnight, and there were interesting blog posts about, wow, how the capability changed overnight. In terms of voice, if you're using anything like Siri, then how does it figure out that you're saying, hey Siri, and filtering out from everything else? This is again using deep learning, and you can find on Apple's website a little bit more information on that. In terms of images, self-driving cars or surveillance technologies have advanced a lot because of the ability to do image recognition, image labeling, what they're actually seeing. And some websites combine a bunch of these different technologies. For example, TikTok say that they use both computer vision, so they're looking at images, they're looking at sounds, and they're looking and capturing video information. Deep learning has also gotten roots into some of the traditional applications, such as lending decisions. And remember, 12 years back, it was mostly credit card companies and banks who were making lending decisions. Since then, we see a lot more also in the world of crowdfunding and peer-to-peer lending because of the connectivity and because of the ability to build predictive models that create risk scores that help people who want to invest in these kinds of platforms to do that. Deep learning is very heavily embedded now in many of these applications. For example, there's a startup called Upstart that tells you that they're training their deep learning algorithms on more than 65 million repayment events. So they're using tons of data on lots of repayments on more than 1,600 variables, and that is using deep learning. Deep learning is, of course, also now embedded and created new applications that were not there before. For example, the Apple Watch uses deep learning to predict stress levels. Another example is Uber, that uses deep learning to predict arrival times. And Uber also does a lot of other predictions. Some of the deep learning applications backfired. Remember, these are black boxes, so there's a lot less control over them by the data scientists who are running them. For example, when Google launched their image labeling service that was based on deep learning, it very quickly backfired because it was tagging some people in very racist ways, and that quickly had to be fixed. So diagnosed and then fixed. And that is a classical thing that we're seeing with a lot of new technologies that use deep learning. They're launched, serious problems emerge, people diagnose them either in the research community or the journalists or someone else, and hopefully sometimes they're able to be fixed. Another example is in the Tesla self-driving cars that use image recognition, and it turns out that they were failing to detect children with their deep learning algorithms. A third example was a chatbot named Tay that was released by Microsoft on what used to be called Twitter in 2016. And this chatbot was learning from tweets and other people on Twitter, and very quickly it became terribly offensive and racist, and Microsoft had to take it down. Notice that this deployment of a chatbot that's based on machine learning and deep learning backfired so badly that now companies are really hesitant to unleash chatbots for consumer facing that are based on machine learning. Predictive solutions, again, were many times used in order to solve a problem of resource allocation. College admissions, where you have a fixed number of seats, or hiring, where you have a fixed number of jobs, or policing, where you have to decide where you're deploying your police force. And I talked about several of these applications that were starting already in the 2012 video. I talked about predictive policing, about predicting juvenile delinquency, about predicting outcomes on MOOCs and online learning platforms. And many of these are definitely still around and growing. And you can even see, for example, on the Microsoft website, underneath their government area, they talk about predictive policing and solutions there. But the interesting thing that happened since 2012 is that many of these algorithms were discovered to have serious ethical and societal issues. And awareness to these issues is a major thing that evolved in the last 10 years. One of the earlier resources that raised serious awareness to this was the book called Weapons of Math Destruction by Cathy O'Neil. And she talked about some of the major issues related to college admission, or even ratings of teachers by algorithms, hiring algorithms, criminal justice algorithms. She talked especially about issues of bias, about feedback of wrong predictions, and much more. And since then, there's constantly articles and papers about problems, ethical problems, societal issues that are coming up because of the use of algorithmic machine learning and deep learning in these kinds of decision making for resource allocation. A recent BBC article talked about how the AI hiring tools, many times they're used for CV screening, are actually filtering out really good job applicants because they're using body language analysis. And that is actually many times not a very good indication of whether this is a good job applicant. So search for things like this and you'll find many of them happening in the last 10 years. Another big application that happened in the last 12 years is a proliferation of risk prediction tools in the criminal justice area. And this is a slightly old statistic that over 200 predictive-based systems are being used worldwide. Who uses them? Judges, probation officers, parole officers, prison staff, courts, police. So they're used by many different entities within the world of criminal justice. And not only that, they're used for a whole lot of different kinds of decisions. So they're used for pre-sentence reports, parole decisions, probation supervision, prison unit assignment, pretrial incarceration, and even domestic abuse protection. There have been two kinds of serious issues that were coming out, among others. The journalistic organization ProPublica published an early article in 2016 showing serious racial bias by some of these recidivism risk prediction tools. For example, they were showing that a white and an African American who had kind of the same profile would have very different risk scores by this system that was called Compass. There's another kind of problem that has been flagged, which is the prediction errors and the impact of prediction errors when they're just made by algorithms, and the humans who make the decisions just take those predictions and don't infuse their own decision-making abilities. So this is an example, a recent example about a pretty tragic case of a woman who was killed by her husband because the algorithm was flagging her husband, who was a domestic abuser, as non-dangerous. Of course, issues of bias and prediction errors exist even before we had algorithms. Human judges, and anyone has their own biases, and those were problematic. The algorithms were supposed to solve the human bias and solve the prediction errors, but what we find that they also have their own kinds of bias because of the data that they're trained on and other reasons. And the question is, how can we identify these kinds of problems, and how can we, or whether we can actually solve them? The other field that made a huge advance since 2012 is not just the predictions for decision makers, but the world of recommender systems. Back then, I had videos on association rules and collaborative filtering, but the world kind of changed a lot since then. How did it change? First of all, there's a lot more data on users across different websites and apps. So when you see recommendations for an Amazon product outside of the Amazon website, that's why it's happening. Secondly, there's been a huge move away from explicit behaviors, for example, when you as a person rate a certain content, to the use of implicit behaviors, things about you, how you're interacting with the app, for example. A third change is that now there's a whole lot more use of what we call contextual data. It's information about your location, about the device that you're using, about the time of day, the day of week, and that turns out to be very predictive, and that's why recommender systems many times use this kind of information to offer you recommendations. A fourth change is the integration of what's called persuasive technology. Persuasive technology is a use of techniques from psychology that are built into devices now that make it much more addictive and enticing and shapes our behavior. I'll talk about this a little more in a minute. A fifth difference is a move from older techniques such as collaborative filtering and association rules to reinforcement learning, where the machine interacts with a human and uses the human feedback in some kind of trial and error way to optimize the firm's goal. So the firm can actually specify up front what is the business goal, for example, long engagement, and based on that, the data are collected about you and the model is built. And finally, recommender systems now also exist as off-the-shelf software, so that many organizations, such as news organizations, don't have to build their own recommender systems, but rather they can just buy some software. One example is Taboola that you might have seen on some websites. So in a recent paper that we published on personalization on platforms implemented in recommender systems, we created an image just showing how things changed over time. And you can see, for example, how in the early 2000s, the machine learning was using explicit feedback. You would be rating content, and the rating would be determining the recommendation. Whereas things have really changed and moved more to implicit feedback, how long you've been watching the movie, or what you're actually doing online. You also see the move to reinforcement learning, and more recently, embedding deep learning into the reinforcement learning, and that's called deep reinforcement learning. Let me give you an example. Netflix has been around since my old videos, so let's see what changed there. At the beginning, Netflix used to ask users to rate every movie that they watched on a 1 to 5 star system. They changed that at some point to just ask you to do a thumbs up instead of the 5 stars or thumbs down. But it turns out that's not the only change that happened. If you go and search on the Netflix engineering blog, for example, you'll find information about how their recommendation systems works now. So they use not only the ratings that you did of this movie and other movies that are similar, but they also look at other members with similar tastes and preferences. They look at your viewing history. They look, of course, at information about the title itself, but also notice how they look at contextual data, the time of day you're enjoying Netflix, what time is it now, the languages you prefer, the devices you're using, and how long you've been watching certain things. So there's a lot more information that's being used compared to what used to be happening in the old days on Netflix. Another change is that now a company might be recommending many different things. So not just a movie, for example. And recommendations can be for content, but it can also be for connections for other users, for example. Think about LinkedIn. LinkedIn was purchased by Microsoft recently, and they also purchased another company that does online courses called Lynda. So what does LinkedIn recommend? LinkedIn recommends courses. LinkedIn recommends jobs. LinkedIn recommends articles, news articles for you to read, updates from other people you're connected to, and it also recommends connections for you. How does it give you these recommendations? Well, now it can do it on the app. It can send recommendations through the messaging app that they have, and they can send you emails. There's a whole lot of different channels where these recommendations can actually be delivered through. What kind of data are being used for them? There's a ton of data. Again, 360 data, because Microsoft and LinkedIn and Lynda and more have information not only your profile on one of these websites, but on a lot of them. They have information about your network, who you're connected with, the network where you're connecting to other users, other groups, your engagement on the apps and on the websites and with these other people, the posts that you're putting on there, your likes, your interactions with other people, your location, of course, and a lot of these other kinds of implicit data. Now, you might also see that companies use terms such as interests, experience, skills, and preferences that are not always necessarily what you would call your interests or your experience, but that's what either they tag your information as, or else they had fields that you had to fill in according to these labels. If you again go to the engineering blogs of these companies, you will see some examples of how they set up things. So this is just a little example of how the LinkedIn engineering blog uses the profile data and the activity data and course metadata. And this is all used from the offline database to create recommendations. But in parallel, they have a little online case where in live, they're doing A/B testing, which is, again, still very common and pervasive across the web companies, and using all of this infrastructure to generate recommendations. As I said, a huge new thing on the block, a new kid on the block, is persuasive technology that is now embedded in almost everything, every app that we see. And persuasive technology are persuasive methods designed from cognitive psychology, initially designed for things like improving your life and making good, eating decisions, but now really captured for how do we keep you longer on the app? How do we make you click or go to wherever we want you to go? So these persuasive techniques, when they are embedded into digital devices, they're called persuasive technology. So if you're seeing notifications on your mobile phone, or you have endless scroll on the email or on other websites, all these are techniques to try and persuade you to do something. So now we're not only predicting your behavior, but we're also persuading you to do certain things. And the pervasiveness of persuasive technology is a huge thing to notice. In fact, it went so wild that in some cases there's even illegal things going on. The limit between persuasion and deception is kind of a gray line. For example, travel websites such as Booking.com, Expedia, Hotels.com, Agoda, they were actually sued by the UK-based Competition and Markets Authority because their use of persuasive technology was actually deceiving the users. If you've seen these things like, there's only one room left at this rate, that turned out to be wrong when journalists went and tried to figure out what were the real rates and how many more rooms were there. So the authorities tried to sue them. Some of them corrected their ways and some of them have not. This is an ongoing battle that happens. Coming back to this big story, what really changed in the last 10, 12 years is scale. We see many more applications of machine learning being used in business analytics. There's tons more training data, much better for training. And there's a bigger use of complex, huge models like deep learning and reinforcement learning. Now you might be asking yourself, well, what's going to happen in the next 10 years? It's very hard to tell, but for sure, predictive analytics are going to merge with the new kid on the block, which is generative AI. All the ChatGPTs that we're talking about right now in 2024, they're probably going to get connected with all the machine learning applications that we've seen before to create better interfaces or maybe other kinds of innovations. The humans and the computers are becoming a lot more connected through this new generative AI, and I anticipate that there will be a lot more human-computer collaboration, hopefully in a more positive way, not in a way where the computer does things to us when we're unaware. So hopefully the human judgment and the human intelligence will be actively embedded and combined with the computer's strengths. There are two fields that are now very strong in the research world in machine learning. One is called causal machine learning, and the other one is called explainable AI. Causal machine learning looks at how we want to generate predictions that are somehow based on causality. For example, predicting what will happen if I show you this ad. What will be the effect of the causal intervention of showing you an ad? The other field of explainable AI kind of came out of the use of these big black box deep learning models where we don't really understand why the model predicted a certain prediction. So for example, if you have a model that predicts someone to recidivate or to not get a loan and they want to know, why did I get this prediction? Explainable AI is a set of methodologies and techniques that are trying to answer the question, what did the algorithm use in order to make this prediction, and what would have maybe changed the prediction had we had other kinds of inputs. So I think definitely watch out for these two fields. Whether they translate into practice or not, that's going to be a good question. What I really hope is that the regulation on all of this that has started with the GDPR in the EU will really catch up faster and catch onto the important points of where machine learning can cause serious damage and where we really need to protect users and society. We've seen now some things gone rogue. Of course, there's beautiful promise and progress and great things that are happening, but there are also a lot of dangerous things and unhealthy things, and it's very hard to stop them once they've started. So I hope that the regulation will become better and stronger on the important points. But the truth is, we don't really know what's going to happen because things become more complex. I would say that if you think about things that didn't work, it will give you some ideas about innovation. If you remember a long time back, Amazon had this cool idea that they would ship things even before the user bought the product. In an article from 2023, they said that actually didn't work out. Amazon and anticipatory shipping didn't really work out. I'll let you read the article, it's kind of cool. And what they did invest in when they saw that this is not working. They found the bottlenecks and tried to figure out how to solve those. So my big question for the next years is, will machine learning be used more for predicting behaviors, or will it be used more for shaping human behaviors? Or is it going to be some interesting combinations of both of these, which we're already seeing, for example, in recommender systems? So these kinds of questions and what kind of issues are going to arise and what kind of good things and dangerous things are going to happen, I think are the interesting questions for the next 10 years.